Here's a simple scene setup where we have the wall mesh breaching through the surface of the ground. And let's use RBDLab add-on to simulate this rigid body simulation. So first, let's head to the top view and let's turn on the X-ray mode. So what we would like to do is to have more fractures along the length of the wall. So for that, let's draw a few fault lines along the wall mesh using the Annotate tool. So let's head to the Prepare tab, and under Annotate, let's start to annotate. Let's press Shift 4 to turn the view, Control Space Bar for full screen, and N. There we go. Now let's draw a few fault lines along the length of the wall. So the more number of fault lines, the more number of chunks we're going to have. There we go. Now let's end the annotation and let's head to Scatter. And let's select the ground mesh, and then let's add standard scatter. And let's keep the density at around 160 and click on Accept. And for the source, let's use Own Particles and Annotation Pencil. And for the max chunks, let's use 3500. And let's click on Fracture. There we go. Let's turn off the X-ray. And let's press 5 for user perspective. And to these chunks, let's add extra details. Here, let's increase the number of subdivisions to 4. So we can actually see the inner details here. And we can see that there are a few bad chunks here. So we can select either these chunks, say select bad chunks and auto fix. Right here, auto fix. Or what we can do is we can just select all the chunks and select bad chunks. There we go. Still we have a few. So let's click on auto fix. Looks good. There's still a little bit of overlap here, but let's see how it looks like. Let's apply the fracture. Looks good. So by default, we would only see the low resolution mode for viewport performance, but anytime we can change it to high resolution. And let's turn on pretty shading. There you go. Looks good. Cool. Now let's save this as fracture. Now let's head to the physics module and let's add ground. And let's scale the ground appropriately. And let's move the ground. Since there's an overlap between the chunks and the ground, there's a high chance that the chunks are going to explode. So let's move the ground in the Z direction. And then let's choose vertex in the snap tool and enable the snap. And then move the ground in the Z direction so that it snaps right at the bottom of the chunks. So there won't be any overlap between the chunk to the ground. Looks good. And let's turn off the visibility. And let's move to the RBD tab and let's add rigid bodies. Perfect. Now for the wall mesh, let's add rigid body to the wall mesh as well. So let's disable the rigid bodies for now. Now this is a simple animation for the wall mesh. So I just keyframed the location at frame 10 and also the location at frame 300. And the wall mesh moves between these two locations. And that's the simple animation. So for this wall mesh, let's head to the motion module. Under quick rigid bodies, let's set RBD. And let's change the type from active to passive. And let's click on kinematic because the animation is keyframed. And let's change the shape from convex hull to mesh. This improves the accuracy of the simulation, and the mesh interacts with the rigid body simulation. And let's reduce the friction to 0.2. And let's click on collision margin, and let's have a very small collision margin. Now let's enable the rigid bodies here. And as we can see, a 30 FPS simulation is running at 3 FPS because there are so many chunks. So what we can do is we can actually make use of this bake module and then bake the simulation between frame 1 and frame 400. Let's click bake. All right, now that the bake is complete, let's play the simulation. Cool. So that's the simulation we were looking for. Now let's save the file as fracture_RBD. Let's turn off the snap tool and enter mesh visualization options. Let's click on high detail and let's turn on pretty shading and let's take a look. Since we've turned on high resolution and pretty shading, the FPS dropped. So what we can do to view this in real time is do a Flipbook render. So let's do a quick Flipbook render. Let's play the Flipbook render. Cool. That's the basic simulation we're looking for. Let's get the viewport back to low, pretty shading off. And let's save the file. Let's continue the workflow and add debris, dust, and smoke in the particles module. So the first tab here is the debris, and we have two options, broken and motion. So both of these are clicked, and at this threshold distance and at this threshold velocity, the particles are emitted. So we can increase or decrease. I'd like to keep this at a minimum. And the particle system limit, let's use one particle system. We can increase the particle systems as well, but this uses more system resources. So for this example, let's keep it at 1. And then let's click on force update broken motion. And then let's create debris. Perfect. So these are the chunks which would generate the debris, the ones in the red. Now let's increase the size of the particles to 0.3. And let's increase the count to something like 150. And let's use ended trails. And here, these are the number of frames for which the debris particles are going to be emitted. So let's change this to 20. And let's click on update to update the changes to all the chunks. And let's head to the physics tab. And here, let's increase the object velocity to 1 and randomize. Let's leave it at 1. And let's give it a z direction velocity of 1 meters per second. And the time step, let's keep it at 0.02 for a little bit of slow motion effect on the particles. And let's click on update. All right, let's take a look. There we go. We see the particles emitted. Perfect. Now let's head to the dust tab. And similarly, let's have the broken and motion clicked and at a very minimum distance and velocity with the particle system limit at 1. Let's click on force update broken motion and create dust. Now let's first head to the emission tab and let's increase the count from 600 to something like 500 and use end trails, and let's use 30 frames and click on update. And under physics tab, let's change the z direction to 1 meters per second and object velocity to 1 meters per second and randomize at 1 and time step at 0.02, and let's click on update. All right, let's take a look. There we go. Here we can see a lot of dust particles as well. Cool. Now let's head to the smoke tab, and with similar settings, let's create smoke. Now let's head to the emission tab and let's leave the count at 500, and let's use end trails for smoke as well, and let's try using 20 frames for smoke emission and click on update and physics. Let's increase the object velocity to something like 0.5 and let's leave the rest of the settings as it is and let's click on update. Let's take a look. There we go. So the white particles that we see are the smoke particles. Looks good. Let's save the file. Now, as the simulation is running, we can see that there is no collision of particles to these chunks. So the debris, dust, and the smoke particles are passing through the chunks, so which isn't very realistic. So we're going to add collision of the particles to the chunks and also to the wall mesh. So for that, let's head to the collisions module and let's select the wall mesh, and then let's add a single object collision to the wall mesh. Add collision, and let's keep the stickiness at 0, damping factor at 0.8, and friction factor and random friction at 0.2 and 0.2. Cool. Now let's head to the collision tab. Now here we would like to add collision to the entire collection. So we can actually select the chunks and then add collision to selection, or we can add the collision to entire collection. The collision to entire collection takes a little longer to compute, but in this case, I'm going to use that. So with the start at 1 and end at 400 and frame step at 1, let's add collision to the entire target collection. Before that, let's just save the file and let's save this as collision. And let's add collision to the entire collection. And it'll take a while to compute. So we have collisions added to all the chunks, and these are the collision settings. Now let's head to the bake module and bake the particles right here. Let's click on Bake All Particles. Now that the particle bake is complete, let's save the file. And let's also save the file as collision removed, as we are going to remove the collisions as the particle bake is already done. So let's head to the collision module. Let's remove collisions on the chunks. And let's remove the bake action. And let's head to the single object collision. And let's click on the wall mesh. And let's remove collision. And let's save the file. Now let's head to mesh visualization options. And let's get the viewport to high. And let's turn on pretty shading. And let's do a flipbook render to take a look. But before that, let's head to the particles and let's uncheck the visibility of the smoke particles, because you'd just like to see how the debris and dust interact with the chunks. So viewport in high detail and pretty shading on. Let's do a flipbook render. Let's play the flipbook render. Looks cool. Now let's get the viewport back to low detail and pretty shading off. And under particles, let's turn on the smoke particles. And let's save the file as smoke. And let's move to the smoke module. And here, let's add smoke from particles since we already have the particles baked. And let's click on Add Smoke. There we go. Here's the domain. And for viewport performance, let's turn off the viewport visibility for the debris and the dust. Let's keep the smoke on. There we go. Viewport is much faster. Now let's first adjust the domain. Right, that looks good. Now let's first go to the flow emitter. And under sampling substeps, let's increase this to 5. And then initial temperature, let's get it down to 0. And density, let's leave it at 1. And let's click on Update. Let's leave the rest of the source settings the same. Let's head to the domain. And under resolution, let's change the resolution to 256. And let's decrease the threshold to 0.0001. And then let's use noise. And noise upres scale, let's use 3. And then for collision, let's use the bottom border collisions. And under gas, let's check the buoyancy density to -1 so that the smoke falls down. And heat, let's give it 0. And vorticity, let's give it 0.1. And then dissolve, let's dissolve in like 30 frames. And then under cache, let's change this to all. And let's keep the remaining settings. And let's save the file. And let's bake. And if you want to pause and resume the bake in between, we can click on resumable. And we can press escape and pause. And then take a look at how the smoke looks like. And then click on resume again. But in this case, I just like to bake all and then take a look. So let's click on bake all. Now that the bake is complete for the smoke, let's save the file. And under particles, let's turn off the visibility for the smoke for now. And let's take a look. And there we go. Looks good. Let's turn on the debris and dust. And under mesh visualization, let's get the viewport to high and pretty shading on. And let's do a flipbook render. Let's play the flipbook render. Now for shading, we can head to the shading tab and cycles preview. There we go. And we can change the color. There we go. And we can also use noise upres here. We use noise upres of 3. We can also upres to 5 in order to get more detail. There we go. That's how it looks like. There we go. So that's the simulation we were looking for. Here's another test with 256 resolution and a noise upres scale of 5. Let's do a flipbook render. Let's head to particles. And let's turn on the debris, the dust, and let's turn off the smoke visibility. This is for the particles, not the actual smoke. And let's do a flipbook render. Let's play the flipbook render. As we can already see, an upres of 5 has much more detail than upres of 3. So the more resolution and the more upres, we're going to have a more detailed simulation. Hope you enjoyed this tutorial. Thank you and stay tuned for more tutorials.